The Earth's surface conceals gigantic chasms, wider than most could fathom. From massive fault lines stretching for miles to immense canyons formed by powerful earthquakes, join us as we show you the top 15 widest cracks in the Earth. Number 15. The Well of Hell. Nestled along the picturesque cliffs of the French Riviera lies a natural wonder steeped in intrigue and legend. This is Le Puits d'Enfer, or the Well of Hell, a captivating crack plunging 100 feet long and 30 feet deep into the coastal landscape. Formed through the relentless erosion of ocean waves and winds, this rocky fissure stands as a window into the geologic forces that have shaped this scenic stretch of coastline. Yet beyond its scientific significance, the Well of Hell beckons visitors with its air of mystery. According to local lore, the Well of Hell is believed to be a gateway to the underworld. Tales describe the doomed fates of those lured into its depths by ethereal voices and eerie sounds. A common legend tells of a shepherd who descended into the chasm searching for a lost ram. Lured deeper underground by enchanting singing, the shepherd discovered a grotto adorned with shimmering crystals and wondrous rock formations. But this paradise, it turned out, was a deceitful illusion meant to trap the unsuspecting shepherd in the underworld forever. While most tales surrounding the Well of Hell remain in the realm of myth, one sinister story rooted in reality has solidified its eerie reputation. In 1949, the corpse of a wealthy Parisian named Robert Taylor was found floating in the flooded depths of the well, along with a waterlogged trunk containing his battered remains. The grim discovery launched a murder investigation, which eventually revealed his housekeeper, André Ferry, had brutally killed Taylor in a plot with his friend Robert Poulet to seize his riches. Ferry was condemned to death, but later pardoned by the French president. This shocking murder case is said to have been the inspiration behind Alfred Hitchcock's classic thriller Vertigo. Number 14. Rffelljaa Rift Valley. Iceland is renowned as the land of fire and ice, where stunning landscapes have been sculpted by immense elemental forces. Nowhere is this more evident than at Rffelljaa, a monumental crack in the earth that offers adventurers an accessible glimpse into the most fundamental processes underlying the formation of new crust. Spanning approximately 30 feet wide and plunging over 20 feet into the earth, Rffelljaa Rift Valley is living evidence of continental drift in action. This mesmerizing rocky slash reveals what happens when tectonic plates are torn apart at a mid-ocean ridge divergent boundary. Rffelljaa's breathtaking locale along the mid-Atlantic ridge conjures up visions of brave Norse explorers and the alluring frontier between two worlds. Standing atop the rugged cliffs on either side of the rift, you can almost sense the ancient whispers of saga poets conjuring epic tales of fire and ice. The story told by the rocks here is no less epic. Rffelljaa offers a window into one of the most fundamental forces that shape our Earth's surface, the pulling apart of tectonic plates. This process, known as rifting or extension, is an integral stage in the plate tectonic cycle that creates new crust and forms oceans. Iceland owes its existence to the relentless rifting along the mid-Atlantic ridge. The North American and Eurasian plates are diverging here at an astonishing rate of about 1 inch per year. This has slowly ripped the original landmass apart over millions of years. As the plates pull away from each other, the crust stretches and deforms. Gradually, the land sinks downward between the separating plates to form a rift valley. The sinking and extension create space that allows magma to rise to the surface to fill the gaps with new volcanic material. Number 13. The Pit of Hell. In the vast Karakum Desert of Turkmenistan lies a fiery pit known as the Door to Hell or Darvaza gas crater. This collapsed natural gas field has been burning for over 50 years since a drilling accident in 1971 ignited the methane. The story begins back in Soviet times when geologists were prospecting for natural gas. The ground beneath their drilling rigs suddenly collapsed, forming a giant crater some 230 feet across and 65 feet deep. Concerned about poisonous gas release, they decided to set the crater on fire, thinking it would soon burn out. But the gas kept flowing and the crater kept burning. 5 decades later, the Darvaza gas crater still rages with fire. The surrounding air shimmers from the intense heat radiating from the 69,000 square foot pit. At night, the crater glows a brilliant orange that can be seen from miles away. Locals gave it the name Door to Hell, while geologists refer to it as a gas flare pit. Seeing photos, you might think it's a portal straight into the underworld. But beyond the sinister nickname lies significant scientific insights related to natural gas leaks and fields. The non-stop burning has essentially created a natural laboratory. Scientists come here to study gas emission rates from underground reservoirs. The pit provides a rare opportunity to observe an open flow of natural gas at high pressure and temperature. Researchers can take measurements over long periods that would not be possible with short-term experimental gas flares. The crater has also yielded fascinating microbiological discoveries. Despite the heat and seeming sterility, microbial activity flourishes in parts of the Darvaza soil. Archaea microorganisms capable of surviving extreme environments have adapted to harsh conditions. These findings have astrobiological implications, providing insights into how microbes could potentially exist on other planets under acidic, heated settings like geothermal vents. Darvaza's Door to Hell has opened up a portal into the possibilities of life thriving in Earth's harshest environments. Number 12. Gjarja. Along Iceland Lake Mývatn lies an enchanting geological formation brimming with history, folklore, and natural wonder. This is Gjarja, a rugged lava cave whose rocky walls cradle a hidden hot spring heated by the Earth's geothermal furnace. Entering Gjarja's craggy mouth, you're transported into a magical underground world. Sunbeams streaming through gaps in the cave ceiling sparkle upon vivid aquamarine waters. The pools range from shallow wading spots ideal for bathing to deeper sections reaching 10 feet that require swimming. These inviting geothermal waters remain a steady 45 to 50 degrees Celsius and give off an ephemeral sulfuric scent as gentle steam swirls overhead. Surrounded by the cave's rough-hewn walls beaded with lava droplets frozen in time, a soak in Gjarja's thermal waters offers the quintessential Icelandic winter experience. Locals have assembled here to ward off the Nordic country's frigid weather for generations. This rare confluence of fiery geothermal energy and elemental rock takes shape at the boundary between colliding continents. Gjarja sits squarely atop the volcanic Mid-Atlantic Ridge Rift Zone, separating the North American and Eurasian tectonic plates. The relaxing hot spring exemplifies Iceland's location along this prominent seam between continents. As the plate boundary ruptures and spreads, cracks and fissures form in the surface crust. Over thousands of years, some of these fissures expanded into larger cavities due to interactions with groundwater heated by geothermal activity. Hence, Gjarja's cave-like structure housing the hot spring. The cave's rough walls bear the unmistakable patterns of lava solidification from past eruptions. A few years back, Gjarja made headlines as an iconic filming location for Game of Thrones, appearing on screen as Jon Snow's secret grotto. But it's the real-life history that makes this volcanic cave spring an unforgettable visit. Legends say Gjarja once served as an outlaw's hideout around the 18th century, when hot spring bathing was banned. Locals also know the cave as the mystical home of a resident troll woman. She would lure unwitting visitors into the heated waters before having them for dinner. Number 11. Kjarrboltun. In the steep mountains of southwestern Norway, a formidable boulder defies gravity extraordinarily. This is Kjarrboltun, one of the most iconic geological landmarks in the world. Wedged within a mountain crevasse some 3,200 feet above the fjord below, this enormous rock draws thrill-seekers from across the globe who dare to stand atop its sheer cliffs. Reaching Kjarrboltun involves a strenuous hike through majestically rugged terrain. The surrounding mountains offer spectacular views of waterfalls cascading from dizzying heights and fjords carving through the ancient bedrock. But the real highlight comes when you catch your first glimpse of the mighty boulder itself. One can't help but wonder, how on earth does such an immense rock, estimated at 175 cubic meters, remain firmly lodged between two cliffs without plunging downward? The answer lies in the craggy boulder's glacial origins. Kjarrboltun was deposited by a glacier at the end of the last ice age approximately 10,000 years ago. As the massive ice sheet receded, the boulder was left wedged within a mountain crevasse. The local bedrock is a key factor as well. It's predominantly made of sturdy basement gneisses that formed 1 billion years ago, some of the most ancient rocks on our planet. This provided a secure, resistant surface that could trap the boulder. Additionally, the isostatic rebound played a role. As the heavy ice sheet melted away, the land began slowly rising upwards, like a cushion regaining its shape. This upward flexing of the crust helped squeeze Carrickbolton into place in the narrow slot between two cliffs. Number 10. Silfra Rift. Beneath the glaciers of Iceland lies an underwater world that dazzles all who plunge into its crystalline waters. This is Silfra, a tectonic fissure created by the separation of continents and filled with some of the clearest water on Earth. This unique rift valley filled with meltwater from the Langjökull glacier invites divers and snorkelers into a realm of unparalleled visibility, where every minute detail stands in sharp focus. In the cold, glacially filtered water, visibility can exceed 300 feet. Swimming between the sheer rock walls feels like floating in an abyss of light and shadow. Silfra owes this exceptional clarity to its unusual geologic story and position on the mid-Atlantic ridge. Here, the North American and Eurasian tectonic plates are slowly drifting apart at a rate of about 2 centimeters per year. This tension has gradually torn the landscape open along the spreading ridge, creating fractures and fissures in the crust. Over time, the cracks filled with water from Langjökull's meltwater, which passed through porous volcanic rock that filtered out any particles or sediment. The result is an underwater world renowned for its crystal-clear waters and fascinating geology. In fact, Silfra is considered one of the top 10 dive sites on Earth. The rift itself is divided into several segments spanned by uniquely shaped rock formations. There's the cathedral, with its soaring underwater cliffs, and the hall, marked by more narrow walls dotted with cracks that beam with rays of light. Adding to the spectacle are the kaleidoscopic colors created by light filtering through the water. As the plates move apart, fissures like Silfra will gradually widen, its walls will collapse, and one day a new ocean will open up between America and Europe. For now, we can experience the earliest chapters of continental separation in one of nature's most magical underwater realms. Number 9. Kamoamoa Fisher. On Hawaii's Big Island, the slopes of Kilauea volcano grow a little bit larger each time its summit or rift zones erupt. This ongoing accumulation of lava flows contributes to the island's growth, as it has for hundreds of thousands of years. In 2011, a rift zone eruption along Kilauea's eastern flank created a new rocky outcrop with its own unique story of fiery creation. This was the Kamoamoa Fisher, which dramatically burst to life, offering a vivid look into the persisting volcanic processes expanding Hawaii's lands. The events leading up to Kamoamoa's emergence begin with increasing unrest detected at Kilauea, starting several months prior. Rising levels of magma prompted swelling of the summit's lava lake. Several miles away, the Pu'u'o'o cone also showed signs of reawakening. The buildup culminated in March 2011, when an intrusion of magma propagated along the volcano's east rift zone. This triggered the eventual breakthrough and eruption from a new fissure roughly 3,000 feet long on the night of March 5th. Lava fountains shot as high as 80 feet from a series of vents lining the fissure. Within hours, fast-moving lava flows were streaming downslope. This inaugurated the beginning of the Kamoamoa eruption and the birth of a new section of Hawaii's landscape. Over the next several weeks, lava spewed forth in a captivating display of creation and destruction. Hitting the slopes, some flows advanced rapidly at rates exceeding 6 miles per hour. More than 100 acres of forest were consumed by the advancing lava. By early April, the eruption shifted into a more stable phase, characterized by steady output that gradually built a broad lava field. This new land ultimately covered about 245 acres in sticky, barren lava rock. While Kilauea's East Rift Zone sees frequent eruptions, the volatility of the Kamoamoa Fisher, combined with its accessibility close to Hawaii Volcanoes National Park, made it especially memorable. Seeing fresh Pahoho lava emerge from the earth and rapidly override all in its path highlighted nature's awesome creativity and power. The eruption produced a new tongue of rock, bulging out from the Big Island's southeastern Puna coast. Visiting the area today, you can walk across this youthful land birthed from the fiery depths just over a decade ago. Number 8. East African Rift. Stretching over 2,900 miles from the Afar Triangle down through Kenya and Malawi, the East African Rift stands as one of Earth's most extensive and visible tectonic plate boundaries. This giant crack in the planet's surface marks where the African continental plate is slowly splitting apart. The East African Rift's sheer scale vividly illustrates the tremendous forces operating deep below the surface that continually reshape our planet. Currently, the African landmass is divided into two plates, the Nubian and the Somali. As they gradually pull away from each other, the landscape stretches and tears to accommodate the strain. This rifting process first began around 30 million years ago and continues today as the Horn of Africa continues to slowly drift apart. Currently, the Rift Valley widens by approximately 2.5 inches per year in some areas as the plates diverge. Stretching thousands of miles through Ethiopia, Kenya, Tanzania, and surrounding nations, the East African Rift exposes a real-life example of continental drift unfolding in real time. The Rift Valley floor vividly showcases this story of planetary change written in solidified lava and violent upthrusts. In the northern Afar region, the rift has advanced to the point where a new ocean basin is actively forming. Here, underground magma easily breaches the thin crust and surfaces as lava, creating a new oceanic crust. To the south, where extension is just beginning, rifting occurs over a wider region with limited magmatism. The East African Rift has also impacted human history, serving as the cradle for where our earliest ancestors emerged. Many exceptional hominid fossils have been discovered in Olduvai Gorge and other areas along the Rift Valley. These rich archaeological findings reveal how our forebears evolved near these dynamic cracks in the surface. Number 7. Thors Well. Along a rocky headland on Oregon's rugged coast sits a curious hole seemingly drilled into the shoreline. As waves crash in and out of the opening, this geological phenomenon comes alive, creating an entrancing window into the raw oceanic forces that batter the Pacific Northwest's stunning shores. This locale, known as Thors Well, offers a preview into the perpetual churning and changing along the edge of land and sea. Thors Well began its life as a sea cave, carved out ages ago by the relentless hammering of wave action. Weak points in the headland's volcanic rock eroded over time, forming an underwater chamber. Eventually, the cave's roof collapsed under the unrelenting pressure of pounding waves, revealing the circular opening we see today. Now, when tides peak, the site transforms into a dynamic scene of spray and foam erupting out from the hole as it fills and empties with the surging ocean. Approaching the opening, you can peer into the darkness of the 20-foot-deep rocky shaft, but observing from a safe distance is highly advised, especially at high tide when unpredictable surges can catch visitors off guard. Videos of Thors Well in action showcase its mesmerizing environment. Waves violently churn into a whirlpool inside the hole as the water gets sucked down and then explodes upward and outward. The repetitive cycle makes it appear as if the coastline itself is breathing. The ethereal blue glow of the ocean swirling within the rocky opening evokes visions of portals to other mystical aquatic worlds. Combined with the power unleashed, it's easy to see why locals spin tales of monstrous sea creatures, mermaids, and the Norse god Thor himself rising from the depths through this chasm. Number 6. Mataga Fault. A prominent line slicing across Guatemala's landscape tells a story of clashing tectonic forces written over millennia. This is the Mataga Fault, which forms part of the volatile boundary between the North American and Caribbean plates. Stretching approximately 190 miles, it has left a clear imprint of plate tectonics visually etched across Guatemala. The Mataga Fault is classified as a left lateral moving transform fault. This means the tectonic plates move horizontally alongside each other, with the Caribbean plate shifting east relative to the North American plate. While this lateral motion averages about 2 inches yearly, it builds up immense strain in the crust. This accumulated stress eventually overcomes the friction locking the plates together, triggering massive earthquakes as the plates jerk forward. In 1976, Guatemala suffered one of its most devastating quakes, a 7.5 magnitude event centered along the Mataga Fault. It crumbled infrastructure, took over 23,000 lives, and left another 77,000 homeless. Beyond triggering periodic tremors, the Mataga Fault's long-term activity has left a permanent mark on Guatemala's terrain. Places where the moving plates have gouged against each other are characterized by broken and crushed rock. Tectonic forces have pushed up mountain ridges parallel to the fault. There are visible fabric faults in the landscape where rock layers appear offset. In some spots, one side of the fault has slid further than the other. Molten material has also surfaced through fractures to form volcanic chains near the plate boundary. Now it's time for today's subscriber pick. About 300 million years ago, there was one massive supercontinent called Pangaea. This immense landform, however, was not destined to remain intact. Over millions of years, plate tectonics and continental drift caused Pangaea to gradually break apart into separate land masses that drifted into their current positions. The continents we see today, Africa, Antarctica, Australia, Eurasia, North America, and South America, were formed from the fragments of the original Pangaea. Currently, evidence shows that the planet is entering another phase of continental drift as massive rifts and cracks are opening up across different continents. The Baikal Rift Zone in Eurasia, the East African Rift Valley, and the Rio Grande Rift in North America are examples of giant rifts forming as the continents slowly move and shift. Over the next 5,100 million years, the modern-day continents will drift further apart and may form entirely new continents different from what we see on the globe today. Let us know your thoughts and theories in the comments below. Number 5. Tater Hills. Deep within Arizona's sun-scorched desert landscapes lies a web of cracks and fissures that continue to grow year after year. These are the Tater Hills, a striking example of giant earth fissures formed by excessive groundwater pumping that has caused the land to sink and split apart. The first fissures emerged in this region back in the late 1950s as agriculture expanded and groundwater pumping escalated. By the 1970s, a maze of gaping cracks up to 25 feet deep already scarred areas around Apache Junction south of Tater Hills. Eventually, they spread northward to the Tater Hills region as well. Today, there are around 15 named fissure zones in the area, constituting one of America's most extensive crack systems outside of an active volcanic setting. Spiders, snakes, lizards, and other desert fauna have made these cracks their home. Back in 2017, aerial surveys conducted by the Arizona Geological Survey revealed a 2-mile-long megafissure tearing through the earth in Tater Hills. It stood as one of the longest recorded fissures in the entire region, an impressive feat in a zone already littered with earth splits. What causes these dramatic cracks? The primary driving factor is land subsidence, meaning a sinking or lowering of the ground. This occurs when water is extracted from underground aquifers faster than it's replenished over long periods. Eventually, the geology can't support the missing volume. The ground sinks downwards into the space left vacant by the depleted water reserves. This creates voids beneath the surface. When the empty gaps grow large enough, the land overhead cracks and collapses downward into the cavities. The earth fissures often form close to the edges of subsiding basins or near bedrock highs as stress fractures propagate to the surface. Once initiated, the cracks continue enlarging over time as subsidence persists and surface strain keeps accumulating. Number 4. Kumbu Icefall. High up in the most iconic mountain range on Earth lies one of the most treacherous and spellbinding landscapes anywhere, the Kumbu Icefall. Nestled at the head of the Kumbu Glacier on Mount Everest, this frozen labyrinth forms the first major obstacle facing climbers on the South Col route up Everest. Crossing it requires navigating a constantly shifting maze of enormous ice blocks and deep crevasses using fragile aluminum ladders. There's perhaps no more visually stunning place on Earth that encapsulates the raw power and dangers of glacial dynamics. The Kumbu Icefall's chaotic and unpredictable terrain originates from the unique mechanics of glacial flow converging with Everest's steep and rocky slopes. As the Kumbu Glacier inches down the mountain, the ice fractures and splits apart when it reaches the faster-flowing ice of the western CUM just beyond the icefall. The result is a frozen landscape in turmoil, filled with towering seracs, snow bridges over hidden crevasses, and ice cliffs prone to massive collapses. In fact, huge chunks of ice regularly shear away from the glacier and plummet down in massive avalanches. Climbers attempting to cross this frozen minefield rely on a series of ropes and ladders fastened to the ice by a specialized team known as the Icefall Doctors. They scout a safe route through the ever-changing maze of blocks and cracks before each climbing season begins. Passing through the Kumbu Icefall involves clipping onto fixed lines and clambering up and down seemingly endless ladders. Turn the wrong way or make one misstep, and the ground could vanish beneath your feet. Number 3. Black Point Fissures by Mono Lake. On the arid eastern flank of California's Sierra Nevada mountains lies Mono Lake, an ancient saline soda lake whose eerie tufa towers and underwater springs have molded an otherworldly landscape for eons. Just south of this iconic body of water is a network of cracks and rocky gashes that expose a fascinating story of fire, ice, and geological drama. These are the Black Point Fissures, formed up to 50 feet deep by intense volcanic eruptions when Mono Lake's shoreline covered a vastly larger area during the last ice age. Today they stand as a portal into the dynamic forces that have crafted this unique region. Around 13,000 years ago, pressure building beneath an ancient and much higher incarnation of Mono Lake triggered a series of underwater eruptions. These explosions ejected volcanic materials across the lake bed. In some spots, the debris combined with chemical-laden hot spring waters welling up from below to cement shattered rock and ash into a layer of solidified tufa along the lake floor. But the story was far from over. Geological forces continued rumbling beneath this 17-square-mile expanse of mineral-rich waters, and pressure kept mounting. This prompted the solidified tufa bed to bulge and stretch until it could stretch no more. A series of cracks split the surface, and the Black Point Fissures were born. Spanning over half a mile in length, these gaping rocky fissures penetrate 50 feet or more into the earth with near-vertical walls. Their widths average around 10 feet, but can exceed 30 feet in spots. Hiking amongst them almost feels like wandering through a slot canyon in the desert. The fissures remain relatively accessible to explorers willing to scramble and climb short distances, but venturing to their bottoms requires some rock climbing skills and gear. Those committing to the challenge are rewarded with an up-close perspective on geological forces capable of rippling and rupturing the landscape. Number 2. Rffelljaa. Along Iceland's Snæfellsnes Peninsula, a narrow chasm slices straight through the flank of a mountain. Surrounded by towering walls carpeted in lush green vegetation, this is Rffelljaa, one of Iceland's most enigmatic and dazzling natural wonders. This epic rocky gorge runs over 150 feet long, 300 feet wide, and up to 160 feet deep. One glance at its vertical cliffs decorated with cascading waterfalls and lush blankets of moss tells a vivid story of Iceland's active geological forces perpetually sculpting the landscape. Rffelljaa's name traces back to an Icelandic legend centered around a youth named Rffeldur, who was pushed to his death into the rocky ravine by a ruthless medieval chieftain. This tragic folktale only adds to the allure of descending into Rffelljaa's mossy depths for an up-close experience with Iceland's unique geology. The formation of this spectacular gorge stems from the tectonic movements linked to Iceland's position atop the volcanic mid-Atlantic ridge. Here, the North American and Eurasian plates slowly spread apart as new oceanic crust forms between them. This builds up incredible tension in the Earth's crust. As the tectonic plates separate, the surface landscape gets stretched and torn apart. The resulting cracks and fissures create zones of weakness that get carved into canyons and gorges by processes like water erosion. In geological terms, Rffelljaa represents a tension fracture between separating plate boundaries. Walking through this lush canyon, You can vividly envision the forces that opened up this slashing rocky gorge as North America and Eurasia creep apart. It's living evidence of the active processes continually reshaping Iceland from its volcanic foundations up. Number 1. Oregon's crack in the ground. Along a remote back road in central Oregon's barren high desert lies a narrow, rocky gorge splitting the earth for nearly 2 miles. Plunging up to 70 feet into the crust, this aptly named crack in the ground conceals a world of volcanic intrigue and wonder. The aptly named crack in the ground lies around 20 miles southeast of Bend, Oregon. A short hike through sagebrush plains delivers you to the crack's sudden, gaping mouth. As you descend wooden stairs into the rocky chasm, you're enveloped within a domain of soaring vertical walls, revealing the raw geologic forces that shaped this rift. Towering basalt columns form the canyon walls, testifying to the volcanic origins underlying crack in the ground's formation between 7,000 and 15,000 years ago. Geological forces here caused the Earth's crust to stretch and pull apart. This allowed magma to intrude closer to the surface and solidify into basalt rock layers now exposed by erosion. The crack itself formed as a fissure vent, created when the surface cracks as magma intrudes and parts of the crust subside. While not situated directly along a tectonic plate boundary, Central Oregon's volcanic landscape harbors much geologic activity that can cause local stretching and fracturing of the crust. Walking through crack in the ground today, you'll scramble over massive boulders cleaved from the canyon walls and slosh through shallow pools lined with vegetation. Oregon's damp winters transform the floor into a vibrant ribbon of green, frequented by chattering birds and scurrying lizards during warmer months. Thanks for watching, and we'll see you in the next one.